Hello, my dear students. I am continuing the questions in the atomic structure of chemistry. 12th question: what is the maximum number of the orbitals the that can be identified with the following quantum numbers? N is equal to 3, L is equal to 1, and Ml is equal to 0. Here the quantum numbers are given. That means N is equal to 3, L is equal to 1, Ml is equal to 0. So it is third orbital, and as L is equal to 1, it is p orbital. We can confirm that. For Ml, for this Ml can take the values of -1, 0, and 1. Here, as shown in the figure, for orbitals for Ml -1, Ml is equal to -1, Ml is equal to 0, and Ml is equal to 1. For Ml is equal to -1, it is px orbital. For Ml is equal to 0, it is py orbital. For Ml is equal to 1, it is pz. So as it is shown in this problem, here it is also shown that. So it contains, as per the question given, it contains only one orbital, that is py. So option is 1. Now coming to the 13th question: calculate the energy in joule corresponding to the light wavelength of 45 nm. Planck's constant is equal to 6.63 into 10 to the power of minus 34 joule second. Speed of the light is equal to 3 into 10 to the power of 8 meters per second. Now for this, the wavelength of the light has been given 45 nm, means that is 45 into 10 to the power of minus 9. Speed of the light is 3 into 10 to the power of 8 meters per second. As per the formula, C is equal to n lambda, where C is the speed of the light, n is the frequency, lambda is equal to wavelength. So just substituting in the above one, C is equal to n lambda, we will get that n is equal to, that is frequency is equal to 1 by 15 into 10 to the power of 17. Energy E is equal to h nu. We can substitute the data given for h is given in the problem itself, and we have find out the frequency. Substituting in this and doing the calculations, we will get 4.42 into 10 to the power of minus 8 joule, as it is shown in the problem. So option is 4. So next, coming to the 14th question: the angular moment of the electron in the d orbital is equal to. So we have to find out the angular moment of the d orbital. So actually for this we have to memorize the formula of this angular momentum. Capital L is equal to root of L into L plus 1 h by 2 pi. Then that can be written as root of L into L plus 1 h dash, where h dash is equal to h by 2 pi. Here L is the angular momentum, L is equal to azimuthal quantum number, h is the Planck constant. For d orbital, L is equal to 2. Substituting that L is equal to 2, we can get that root of 2 into 2 plus 1. Root of 2 into 2 plus 1 will get root 6 and h dash. It's very easy, simple calculation only. So option is 3. Just for this we have to memorize the formula for the angular momentum. Then coming to the 15th question: magnetic moment has been given. Magnetic moment is 2.84 bm is given by the atomic number. So which of the following options will give this magnetic momentum number, that is 2.848 bm? Here the number of the electrons, so we have to calculate, we have to see this what is called we have to calculate, we have to see the configuration. For this, if you see the electron configuration, Ni seems to be the that is nickel seems Ni2 plus seems to be the having adequate electron configuration, that is 1s2, 2s2, 2p6, 3s2, 3p6, 3d8, 4s2. The two electrons of 4s orbital has been removed from it to make it Ni plus 2. That is ground state is 4s2 is there. So from that fourth orbital of s orbital, two electrons has been removed to make it nickel into Ni2 plus. The electrons in the third orbital is, so we have to see third orbital. It is having 8 electrons. Third orbital has to be distributed into this 3d orbital as shown in the figure. That means here only outermost two orbitals of the two, there are 2 electrons or odd electrons left behind as it has been shown in the figure, using the rules and regulations of sharing and distributing of electrons in the orbital. That you might be knowing very well, or otherwise if you are not able to know that, just you see that Hund's rule, and then that is a Pauli's exclusion principle, all things into the count, taking into the count, just distribute the electrons into the d orbital. Only in the outermost electron, 2 electrons or odd electrons are left over. So for magnetic moment there is one formula, root of n into n plus 2, n into n plus 2, substituting the value where n is the number of electrons, number of the odd electrons, that is equal to 2. Substituting that, we will get simply 2 root of 8, that is equal to 2.83 bm. That is the option, 2.83 bm. That is equal to, that means Ni2 plus will be having this type of magnetic moment. So for remaining things, we won't get 2 electrons in the outermost shell. Remaining all ions will not be having that much of electrons. So the correct option is Ni2 plus only. The number of d electrons in Fe2 plus is not equal to the number of electrons in which one of the following. The number of d electrons in Fe is equal to 6, and p electrons in neon is equal to 6. Number of electrons magnesium is equal to 6, and that for that you have to see this electron configuration of these elements, so that we can easily find out that p electrons in Cl is equal to 11. So here all the d electrons in Fe2 plus is 6. The number of electrons which is not equal to the Fe2 plus is here, the number of d electrons he told in. So here the d electrons is not available in Cl, so we can say that option 4 Cl should be the correct number, which does not having the number of the p electrons. So as the information given in the question number 16, and in each option we have find out the number of electrons in each orbitals. So in only chlorine only, the number of electrons, p electrons in Cl is 11, which is not equal to the number of d electrons in Fe2 plus. Here only you have to find out the number of electrons as in the orbital as shown in the question given. Then you can easily find out the answer, that is here. So we can say fourth is an option. How many electrons can fit into the orbital for which n is equal to 3 and L is equal to 1. So the orbital corresponding to n is equal to 3, L is equal to 1 is p orbital. So the number of electrons that you can fit is into that orbital is 6 electrons. Only thing is we should know we have to find out which orbital it belongs to, that is p orbital. They are going to say the maximum number of electrons that p orbital can have is only 6 electrons. Option is 2. Next, coming to this 18th question, 2 electrons occupying the same orbital are distinguished by. Actually, Pauli's exclusion, if you know the Pauli's exclusion principle, then it is very easy to answer, because if all the 3 quantum numbers, that is principal quantum number, azimuthal quantum number and magnetic number are same also, the last one should not be at least the last one should not be equal as per the Pauli's exclusion principle, that is spin quantum number. So evidently it is the spin quantum number and option is 4 as per the Pauli's exclusion principle. Next, coming to the 19th, which of the following pairs of d orbitals will have the electrons density along the axis? So if you know this orbital structure and figures, we can easily say that which the orbital having electron density along the axis is 3d square, 3z square. So correct option is 3. And 3d x square minus x square. From the figure itself, it is evident that we can say that electron density is along the axis. So just we have to refer the figure of the d orbitals. Which of the following the wrong statement? The energy of s orbitals is less than the energy of the 2p orbital in the case of hydrogen like atoms. That is, he told that you have to select the wrong statement. All the atoms of energy of 2 orbitals is less than the 2 orbitals, not only in the hydrogen like atoms. The energy of 2 orbitals is less than the energy of the 2p orbital in the case of hydrogen atoms. Actually, it is a general phenomena. The energy of 2s orbital is always less than the energy of the 2p orbitals. He has told that it is in case of only hydrogen like atoms. It is not like so. For all the atoms, it is the same. It is just like the option 1 only. That means here it is told it happens only in the case of hydrogen like atoms, but it is not so. It is happens in all the atoms. So option 1 is the correct. Option 1 is the correct. Next, coming to the 21st question, in which of the following is the wrong statement? The orbitals of angular momentum s orbital is equal to 0. equal to 0 means orbital quantum number, total orbital number, total angular momentum of the electron, because it is symmetrical, so angular momentum of the electron is 0. That is correct only. S orbital is designated by the 3 quantum numbers, while the electron in the atom is designated by the 4 quantum numbers. The orbital is designated by the 3 quantum numbers. That is correct only. If you know up to magnetic quantum number, then you can easily you can find out what type of orbital it is. And if you know the 4th quantum number, then we can say where is the position of the electron, and we can identify electron also. So that is also correct statement. The value of m for d square d square 2 is 0. That is also correct. In the shape of the orbitals it is explained, that one. And in them the electron configuration in an n atom, here distribution is correct only, but the thing is the direction of the lost electron should be upward side. That means the electron should not coming to the opposite spin. All spins in the beginning should be in the same type of spin. That means it should be upward, the last suborbital. That means PZ1 has been shown as downward here arrow. That should not be there. It should be shown in the upward, so that we can say all the 3 p orbitals should have this same spin in the different suborbitals. So that is the incorrect one. So we can say that is the wrong statement. So we should learn the subject understand in an understanding way, and critically you should think it. And we can also think that the same question that has been given in these examinations can be asked in different ways, and how to answer that, we have to think about that also. If you think like that, that is very easy to answer the questions, and you can get the good marks in this one. Okay, for the up to next will the energy of the second Bohr orbit of the hydrogen atom is 3.28 kilojoule per mole. Hence the energy of the 4th orbit should be. So here we have to just use the formula, that is En is equal to, as it is kilojoule per mole, we have to use that formula. En is equal to 1312 by n square, where n is the number of the orbit. For n is equal to 2, we have to substitute. For n is equal to 2, U2 is equal to minus 328 has been given. Then you have to substitute n is equal to 2, that is 1312 by 2 square. Then you will get for n is equal to 4, minus 3 minus 1312 by, if you substitute n is equal to 2, it will get 16. Then you will get minus 82 kilojoule per mole. So where it is available 82, that is in the option 2 only. So correct answer is 2. Okay, going to the 23rd question. Using Bohr equation, here 22 question is just like substituting the value only, nothing more than that. Using the Bohr equation for the energy level of the electron in hydrogen atom, determine the energy of the electron for 4. For that we have to use the formula. En is equal to, so here unit has been given. Joule per atom is 131 minus 1312 by n square. If it is joule per atom, if it is kilojoule per mole, then we have to use En is equal to minus 1312 by n square. If it is joule per atom, then we have to use En is equal to minus 2.18 into 10 to the power of minus 18 by n square. So using that formula, just substitute n is equal to 4, then you will get the answer 1.326625 into 10 to the power of minus 19 joule per atom. That is nothing but option 3. Next, coming to the 24th question, the wavelength associated with the golf ball 200 grams and moving in the speed of 5 meters per second. Here, if you take 5 meters per second and substituting lambda is equal to h by mv, you will get the answer of the order of 10 to the power of minus 34. But in some of the books it has been given 5 meters per hour. That has also has been calculated. If you take that time is that is speed is 5 meters per hour, then it has to be converted into the meters per second. That is equal to velocity is equal to 0.139 into 10 to the power of minus 2 meters per second. Then using the formula lambda is equal to h by mv, we will get the answer 2.3835 into 10 to the power minus 30. That is at the order of the 10 to the power of minus 30. That means if you take 5 meters per second, option is 4. If you take velocity is 5 meters per hour, then you will get the answer of the order of the wavelength of the order of the 10 to the power minus 30 meters. So then it will become third option. So here two questions has been given. 5 meters per hour also I have calculated, and 5 meters per hour also I have calculated. Accordingly, option will change. Don't be confused with that. Okay. Then going to this 25th. If the wavelength is in meters and object mass is 1.g moving with the velocity of 1.10 to the power of kilometers per second, then just to substitute in lambda is equal to hmv, then you will get the answer 6.626 into 10 to the power minus 33. Option is 4. Next, going to the 26th, the uncertainty here also just using the formula delta h delta x, uncertainty principle formula only you have to use delta x into delta p greater than or equal to h by 4 pi. The given data has to be substituted in this one, then delta x can be easily calculated as shown in the problem. 0.175 centimeters you will get. Okay, 0.175 centimeters will get it, and option is 3. So now in the atomic structure is over. Read the subject nicely and think critically, and the same questions can be asked, once again I am repeating, can be asked in a different way also. Then for that you have to prepare in such a way that in what type of the way it can be the question may be asked, you are able to answer that. If you prepare like that, then definitely you can score good marks. Thank you and good luck, students. Then next we will meet in the next chapter. Thank you.